Good evening, everyone. Today we'll discuss about the nature of the light and the properties of the light. First, the concept of the nature of the light. The nature of the light divide the physicists into two classes. Some of them believe and try to prove with their theories that light is having a particle nature, and some of them try to prove the nature of a light. They call that light is having a wave nature. So some say the light is having a particle nature, and some of them are saying light is having a wave nature. Many theories are there, many experiments were done to explain the idea, the concept about the light. The first one was given by the Newton, and that is called a Newton corpuscular theory. What Newton believed, he said that the light travel from one place to another in the form of particles. This is what he took or considered in his theory. But the problem in his theory that he think that light is traveling faster in a denser medium. So Newton corpuscular theory and Newton theory, he suggests that the light is traveling in the form of particle, but the why his theory was discarded, because he considered that the light is traveling faster in a denser medium. But that was wrong, because the experiments were done and the experiment shows that light is not traveling faster in a denser medium. That is why his theory was not complete and it was discarded. That's because this assumption that the light is traveling faster in a denser medium, like in solid the light travel faster as compared to liquid or gas. And his theory was influenced by the sound, because as we know sound is a mechanical wave. Sound require a medium to travel, and the sound travel faster in solid as compared to that of liquid and gas. So his theory was influenced by the sound, and which leads to this wrong assumption that the light is traveling faster in a denser medium. The first physicist to give an concept or give a concept that light is having a wave nature was Hygiene. According to Hygiene theory, he suggests that the light is not a particle, light is not traveling from one place to another in the form of particle. Actually, it is traveling in the form of wave. According to Newton, the particles are there, the light travel in the form of particle, but according to Huygens theory, the light is traveling from one place to another in the form of wave. Again, his theory is also influenced by the concept or the nature of the sound, that as we know that sound require a medium to travel. So to explain the idea that this light travel from one place to another, he suggests that whole universe is having an hypothetical medium, like his assumption is there that whole universe is having or filled with hypothetical medium which we call ether. But existence of the ether, practically the experiments are not able to show that the whole universe is made up of any material or any medium which we call ether. But in a hygiene theory, he suggests that light required a medium to travel, and the whole universe is made up of hypothetical imaginary medium which he called ether. But if something is there, then practically we should it should show a result as well. But the practical existence of the ether is not proof. Again, so his theory was discarded as well. Same like Newton, because Newton assumed that the light is particle having a particle nature, where Huygens said that light is having a wave nature. But this is a wrong assumption that there is an ether in the surrounding or the universe. So the debate goes on. Some of the scientists suggest light is having a wave nature. Some are suggesting light. These are the main theories, but there are even in between the experiments were done to show the nature of the light waves. The first basic experiment which made the scientists believe that the light is having a wave nature is a Young's double slit experiment. The Young's double slit experiment, what he did, he took a highly coherent source and he passes through, like the light source, the wavelength is comparable with the gap size. So he observed a diffraction as well as another thing, interference. So when he plays this screen, this is a screen. On this screen, what he observed the fringes, the patterns of dark and bright fringes he observed. What is the meaning of this dark and bright fringes? It means destructive interference minima, constructive interference maxima. Then minima, like there are some regions where the two rays cancel out each other. There are some regions where the two rays increase the effect of each other. So minima and maxima, this pattern is observed. So it means there is an interference. So using a Young's double slit experiment, this shows that there is an interference, and interference cannot happen for particle. Like example, if you have two particles, if they are moving, they can collide with each other, but they cannot interfere with each other. Interference is a property of the wave. So particle nature cannot explain this interference. Only the wave nature can explain this interference, that make the scientists believe that light is having a wave nature. So first started with the concept of the particle, then Huygens gave an idea about the wave, but still as his assumption was wrong, he assumed that the whole universe is made up of hypothetical medium, that is ether. Later, Young's double slit experiment proved the interference, and interference is a characteristic or the property of the wave. Particles cannot interfere. Particles can have a collision, but it does not have show interference of maxima and minima, like some regions where they increase the effect and some region they decrease the effect. So this make the scientists believe that the light is having a wave nature. Then after this Young's double slit experiment, they work on what kind of wave is it, because Huygens assumed that the whole universe is made up of hypothetical medium and it required this medium to travel from one place to another. So Maxwell Planck explained this idea that light is having electromagnetic nature, like light is an electromagnetic. When we say electromagnetic, the term electromagnetic means that it can travel through vacuum. So Max Planck, a German physicist, who explained that light is having a wave, and it is an electromagnetic wave. So when we say it is electromagnetic wave, it means it can pass or travel through vacuum. Then there is another phenomena later in 19th century. There is an effect which is called a photoelectric effect. So this photoelectric effect can only be explained by a particle nature. We will discuss in detail the photoelectric effect, but photoelectric effect can only be explained by particle nature. Wave nature cannot explain this photoelectric effect. What is happen in photoelectric effect? In this photoelectric effect, when the light in the form of particles fall on the metal surface, these particles absorbed by electron will absorb these particles, and these electron will come out. This can only be explained by photoelectric, by particle nature. It cannot be explained by wave nature. So again, that changes the idea, like the scientists after this Young's double slit experiment and knowing the nature light is electromagnetic, can travel through vacuum. The photoelectric effect, again, that leads to contradiction, because if light is having a wave nature, then the photoelectric effect cannot be explained by wave nature. Only particle nature can explain this. So again, the Max Planck explained that light is actually a particle, and he is the one who used the term quanta for the light particle, or he said light is actually like energy quanta. The particles of the light are energy quanta. What is the meaning of energy quanta? Means the particles which are carrying energy from one place to another. We also call that as photon. And to calculate the energy of the photon, we use the formula E is equals to hf, where E is the energy, H is the Planck's constant, (6.64 exponent minus 34), and F, what is F? F is a frequency. of the source which is emitting out the light. So if we know the frequency, we multiply it by the Planck's constant, we'll get the energy. Or we can directly say energy is directly proportional to frequency. Higher frequency light means carry more energy. And there's also a formula, V is equals to F lambda or C is equals to F lambda. So we can say F is equals to C divided by lambda. So in place of F, if I substitute C divided by lambda, so E is equals to Hc divided by lambda. So energy is inversely proportional to wavelength. What is C? C is the speed of the light, which is 3 exponent 8 or 300 million meters per second. So this formula shows energy is inversely proportional to wavelength. Longer wavelength carry less energy as compared to shorter wavelengths. Is it clear till now? The concept of the nature. So some of the scientists believe light is having a wave nature, some believe light is having a particle nature. Then de Broglie conclude this debate and he suggests light is having a dual nature. Which we also call wave particle duality. So according to wave particle duality, actually what he did, he combined both concept of wave and particle by giving his relation. Look, the things which are related to wave is a wavelength, frequency. The thing which is related to particle is mass and velocity, or we can also say momentum. So he gives a relation, he said lambda is equals to h over p, where lambda is a wavelength and momentum, p is a momentum which is for particle. So lambda is equals to h over p, that is the de Broglie's relation, which shows that light is having a dual nature. When we say light is having a dual nature, it means the light can behave like a wave, the light can behave like a particle. It depends on what condition, what scenario, what effect we are studying. Like example, if I'm studying interference, polarization, these are the properties. It means in that case, I will consider light is not having a particle nature. I will say light is having a wave nature. And when I'm studying a photoelectric effect, line spectrum, so these type of effects are only explained by a particle nature. The wave nature cannot explain these effects. So in that case, we'll say light is having a particle nature. So some phenomena, the light is behaving like a wave, and some phenomena, light is acting like a particle. So what we call this, we call that light is having a dual nature, means it can be a wave or it can be a particle. Is it clear? So light is having a dual nature. It can be behave, it can be a particle. Any doubt until now? So the phenomena which can be explained by wave and particle nature. So if we say reflection of the light, we can explain reflection by particle nature. We can explain reflection by wave nature. So both this reflection can be explained by particle as well as refraction, the change in speed when the wave travel or the particle travel from one medium to another. So reflection and refraction can be explained by both particle and wave nature. But diffraction, interference, polarization, Doppler effect, it can only be explained by wave nature. The particle nature cannot explain these effects. And the effects which can be explained by particle nature, such as photoelectric effect, line spectrum, so these are the effects can be explained by particle nature. Then radiation flux. What is the meaning of the radiation flux? The term radiation flux means number of the field lines, or how much energy is coming on unit area in 1 second. So the definition of the radiation flux is energy coming on unit area in a specific time perpendicular to the surface. So we call that as a radiation flux. So if I make a formula, so radiation flux or intensity is equals to energy coming on unit area in 1 second divided by time. So what is energy divided by time? So energy divided by time is equals to power. So we can say radiation flux or intensity energy divided by time is power, so we can say it is power divided by area. So what will be the unit of radiation flux? Power is watt and the area is meter square, so it is watt per meter square, means how much power on a unit area. That is also known as intensity or radiation flux. So This is a formula which we will use to calculate the radiation flux or intensity. But when we are calculating for a source, like example, if I say we have a lamp, radiation flux from source to certain distance. So when we are calculating a radiation flux from source to certain distance, for example, you have a lamp, a bulb, and you want to calculate a radiation flux at this point P, which is at a distance of R from the source. But radiation flux cannot be calculated for a point. It is always calculated for area. So when we join, like when we will have so many points which are at the same distance away from the source, so what it will make, it will make a sphere. So what it will make a sphere, and the radius is the distance between the source and the point where you're finding the flux. And the formula to calculate the radiation flux or intensity is power on unit area. And what is the area of the sphere? That is 4 pi r square. So that will be, in this case, the intensity will be equal to flux divided by 4 pi r square. And what is r? R is the distance between the source and the point, the position where you are finding the flux. Is it clear? Is it clear to everyone? The flux, the concept of radiation flux. Then the properties of the light. Light can undergo reflection. When the light strikes the surface, it bounces back, it changes the direction. This property is called a reflection. We can take a particle or a wave nature to explain both reflection. According to law of reflection, the angle of incidence and the angle of reflection will be same. So the angle at which it hit and angle at which it bounced back from the normal, that will be same. This is called a law of reflection. The property of a light to change, property of a wave to change the direction when strike the surface, we call that as reflection. And refraction means property of a wave to change the speed when travel from one medium to another. When the wave travels from one medium to another, it changes the speed, and this property is called a refraction. So for this, we will use a Snell's law to solve a question. Example, this is a boundary. Ability of a medium to bend light, that's called refractive index. So N1 and N2. When the wave travels from one medium to another, if the speed decreases, it will bend towards the normal, and if the speed increases, it will bend away from the normal. So it can happen both ways. So according to Snell's law, the angle which it is making in medium 1, that's theta 1, and angle making in medium 2 is theta 2. So according to Snell's law, N1, the refractive index of medium 1, sine theta 1 is equals to N2 sine theta 2. This is called a Snell's law. So now you will use a Snell's law to solve a question related to refractive index. Refractive index means ability of the medium to bend light. Higher refractive index means smaller speed. So we can say refractive index and speed are inversely proportional. So if two quantities are inversely proportional, we can say the product will be constant. So in this part, we can say N1 and V1, and this part N2 and V2. So simply we can say N1 V1 is equals to N2 V2. The product of refractive index into speed is in medium 1 is same as the product of refractive index and speed in medium 2. So we can use these two formulas to work out the refractive index or speed. In O levels, you did the same formula, but in O levels, you used to write n is equals to sine angle I over sine angle r, or sine angle r over sine angle I, because in O levels, when the light was traveling, it was either traveling from air to glass or glass to air. Air is always there a one medium, and the refractive index of air is 1. So example, a light enter from air to glass or air to water. Refractive index of air is N1, which is 1. Refractive index of water or glass is N2. When the light travel from air to glass, it will slow down. So its speed decrease, it will bend towards the normal. So when we draw the normal, the angle with the incident, that's called theta 1, which is the angle of incidence, and angle of theta 2, which is the angle of refraction. When I write the Snell's law, that is N1 sine theta 1 equals N2 sine theta 2. So refractive index of medium 1 is 1, the angle of incidence is I, refractive index of medium 2 is N2, or I can say N, and sine, the angle of theta 2 is a refraction. So when I solve this, you can see sine angle I over sine angle R is equals to refractive index N. And that is the formula you used in O levels. But right now, because in O levels, one of the medium was always air and the refractive index is 1 for air. That's why it was valid. But now here in A levels, the light may travel from glass to water, might travel from water to glass or water to plastic. So even the medium, the refractive index of the medium will not be 1. That is why you will not use this formula. You will always solve the question related to this part using a Snell's law. N1 sine theta 1 is equals to N1 sine theta 1 is equals to N2 sine theta 2. And when we increase the angle of incidence in a denser medium, the critical angle and total internal reflection, the critical angle, the angle of incidence is known as the critical angle. When angle of refraction is 90, as light travel from denser to rarer medium, means high density to low density medium. Example, this is a surface. When the light strike, it will, if it travel along the surface, so angle of refraction you can clearly see it is 90. So the value of the angle of incidence, that is also known as critical angle, for which the angle of refraction is 90. But what is total internal reflection? If we increase the angle more, when angle is more than the critical angle, the light will undergo total internal reflection. This phenomena is known as total internal reflection. So basically what happened, like if you have, there is partial reflection is always there. So some of the light is refracted, some of the light is reflected. Here, when angle is equal to the critical, it will undergo with means travel with 90, and some is still reflected. But when it's more than the critical, the light will undergo total internal reflection. No component of the light is able to escape. As we drew the normal at this position, so if this angle was say 20, this angle is say 30. So this is called a critical angle is 30 here. And example if 35, so it will undergo total internal reflection. If this is refractive index N1 and N2, so refractive index of medium 1 should be higher than medium 2. And we have this formula N1 V1 is equals to N2 V. Is it clear? The frequency remains same, the speed decreases. If the refractive index is high, the speed will be less, so wavelength will be shorter. If refractive index is low, the speed will be higher or the wavelength will be higher. Is it clear? Any doubt related to the class today? So we started with the concept of the light, the nature of the light. Then we discussed the different theories based on the nature of the light, or explaining the nature of the light, the light intensity, and then properties of the light. Any question related to the class today? So I'll end the session and share this recording.